Dear friends, we would be discussing what do you mean by equal vectors. When are the two vectors equal? What is a vector? We said that vector is a arrow, a simple arrow with a direction. So suppose this is arrow, this becomes a vector. Now when the two vectors are equal, they are having the same length and the same direction. So in this case, vectors A and vector B, they are equal because vector A, if you look at the magnitude of the vector A, and if you look and compare it with the magnitude of vector B, this magnitude is same. So this means that these two vectors are equal vectors because not only the magnitude is same, you look at the direction is also the same. Now if you had a case where the magnitude is same, means for example if you look at A and C, you'll find that magnitude of A is equal to magnitude of C. In that case, whether these vectors A and C are equal vectors, they are not, because you find that the direction of A and C are not equal. So the direction is not same. So these are unequal vectors, they are not equal. Now suppose the direction is the same. Now in this case, if you consider vector E and F, you'll find that the direction is the same, the angle is the same, but the magnitude is not the same. If you look at the magnitude of vector E and vector F, you'll find that one is smaller than the other. So E is smaller and F is larger. So such vectors which magnitude is not the same but direction is same are also not equal. So in other words, for the vectors to be equal, the magnitude has to be the same and the direction has to be the same. Magnitude has to be the same and direction has to be the same. Then we would say that the two vectors are equal vectors. So this is a simple concept of equal vectors. Now when do we call the vectors as parallel? Look at these two vectors. Let us call this as vector A and vector B. Now these two vectors have the same angle or the same direction. They have the same angle or the same direction, but the magnitudes are not the same. Okay, so we would say that these two vectors are parallel. So for the vectors to be parallel, they should be pointed towards the same direction. Okay, and these two vectors, if you extend these two vectors also, if you move these vectors, okay, they would not intersect that way. Okay, so parallel vectors A and B are the vectors whose direction is the same. Anti-parallel vectors are also parallel, but the difference that you look at the arrows of these two vectors A and B, and if you call these as vectors C and D, this vector C and D are also parallel in the mathematical sense, but they are having different directions. So this is the direction of vector C and this is the direction of vector D. It means that these two vectors, vector C and vector D, are anti-parallel. So from the diagram itself, it is clear that what is a parallel vector and what is a anti-parallel vectors. And an important concept is what is a position vector. So position vector and the free vectors, there is a subtle difference. If you look at the vector R1 arrow, okay, this is the vector R1 arrow. So this is a position vector because you are drawing this vector in the xy plane and you are fixing position of this vector with respect to origin. So position vector will always start from 0 0. Okay, origin, it will start from the origin and it would be if in the xy plane, and you would see that, for example, if I want to figure out what is the position vector R1, so A, let us say the point A is the point whose position is to be found out. Okay, so how is the position of A to be located? So we draw a position vector from origin O to A with the magnitude x1. So x1, this would be x1 on the x-axis and y1 on the y-axis. So this would be y1, this would be x1, and hence this point A would have the magnitude, the ordinates x1 and y1. The coordinates of A would be x1, y1. Now how is this vector represented? It is x1 in the x direction. So it is x1 into I cap. I cap would be for x direction. What is y1? Y1 is in the j direction. So we move x1 in the x direction. So it becomes x1i, and we move y1 in the y direction. That becomes y1j. So this way, if you want to look at this position of A, this is x1 towards the positive x-axis and y1 towards the positive y-axis. This way we will get the position of A. So we represent it as x1 I cap plus y1 j cap. So this is the position vector. Similarly, if I want to look at the position of B, I need to draw a vector. I need to move x2 along the x-axis. So that becomes x2i, and I need to move vertically upwards, that is along the y-axis, y2j. So the position vector of OB becomes x2i plus y2j. So this is what is a position vector. So the difference between the free vector and the position vector is that free vectors, the starting point can change, but for example the displacement vector, but the position vector, the position is always with respect to the origin 0, 0, and if it is two-dimensional, then it is in if it is in the plane, then it has to be x1i plus y1j, but if it has to be located in the xyz coordinate system, then it would be x1i plus y1j plus z1k. Okay, so this is about the introduction to vectors.